R matey, the purge. The purge. This is a purge solenoid out of a 2015 Jeep Grand Cherokee. They come in all sorts of shapes and sizes, but they all have three things in common: an inlet, an outlet, and an electrical connector. That electrical connector will have two wires, a positive and a negative. That positive will be fed to the solenoid at all times, and the negative will be controlled by the engine computer. The purge solenoid is the gateway between the intake manifold and the charcoal canister. When this is open, fuel vapor from the canister can be pulled into the intake manifold. When this is closed, it keeps these two systems separate, blocked off from one another, so the vacuum of the intake manifold is no longer influencing the charcoal canister. Let's take a look at a quick diagram. We fill up our tank from here. As we fill up with fuel, our vapors are pushed into our EVAP line down into our charcoal canister. Now our canister's charcoal will collect our vapor. Let's say our purge is stuck partially open. Some of those vapors will make their way into our purge line. And depending on how low our fuel tank was before filling it up, that could be a lot of vapor being pushed towards our intake manifold. The next time we start our vehicle, all that vapor, because our purge is open, will be sucked into the intake manifold. This will introduce excess fuel vapors that the engine was not accounting for. Therefore, the vehicle will run rich. That is the cause of the rough running engine after a fill up if our purge is stuck partially open. Eventually though, all the vapors will be sucked out of the charcoal canister, fresh air will be drawn into our vent, and then it'll be just fresh air going in, and the engine will run good once again, once that rich condition is taken care of. Now, if our purge is stuck open, it will constantly be drawing fresh air from the vent into our intake manifold. This fresh air is unaccounted for by the engine computer. The engine computer utilizes either a MAP sensor, manifold absolute pressure sensor, or a mass airflow sensor to calculate how much air is entering into the intake manifold. But this air is not being monitored by the MAP or the mass airflow sensor. It's entering in through a back door, so the engine computer is not accounting for that extra air. Therefore, we get a lean condition. It's possible that that lean condition can cause drivability issues or just a check engine light, depending on how bad our purge solenoid is. Now the easiest way to test these is with a vacuum gauge hooked up to the intake side. Let me show you. With our vacuum gauge hooked up to the intake side of our purge solenoid, all we have to do is apply a vacuum. We'll go up to 20, that's intake vacuum, and just make sure it holds. Give it a few seconds. Now if this had any kind of leak, it wouldn't hold at all. So this is a good purge solenoid. Another way you can, over here. Another way you could test for a bad purge solenoid is with a scan tool monitoring the fuel tank pressure sensor. So let's do that. We're in a 2015 Ford Edge with a bad purge solenoid. Right here's our fuel tank pressure sensor. You'll notice we are at a slight vacuum with the engine at idle. Watch, as I give it throttle, we'll lose vacuum in our intake manifold, and you'll see that we also lose vacuum with our fuel tank pressure sensor. You see that little blip? That's our fuel tank pressure sensor going from a slight vacuum to atmospheric pressure, or no vacuum at all. So with the purge solenoid disconnected, it's closed. It should be closed all the time. So that separates the intake manifold from the fuel tank. It just shuts it off, puts a gate right there in between. So whatever the manifold is doing, it should not affect the fuel tank at all because it's closed off. They're not connected to each other. But if there is a leak, if it is open, even just slightly, then we will see a correlation between what's happening at the manifold and what's happening in the fuel tank. And that's what we were seeing. Even though it was minute, it shouldn't have existed at all. Hello? What if it's an electrical issue? How do you know if it's the purge solenoid or the vehicle wiring? Let's find out. This is a 2005 Hyundai Santa Fe, and the purge solenoid is in the back behind the intake manifold. With my scan tool, I'm allowed to turn on the purge solenoid with a click of a button. It says it's now active. Let me put my microphone by the solenoid. That clicking is the engine computer turning it on and off. That lets us know that our purge electrical is working properly. But what if we don't hear a click? Then we'll have to hook up a test light to check the harness. With a test light hooked up to the harness, when I turn the solenoid on, this should light up. That's the engine computer activating the purge solenoid. If this is lighting up, then we know the engine computer is good and the wiring harness is good. If we're still not getting a click from our purge solenoid, we know the solenoid is bad. Even if you don't have a fancy scan tool, the purge solenoid will kick on as soon as the engine reaches operating temperature. You may just have to wait a little while. What's inside here? When you open this up, you'll see a spring-loaded valve. That spring is putting constant pressure against the outlet that goes to our intake manifold. That creates a barrier or a seal between the manifold and the inlet from the charcoal canister. When you supply a power and a ground to the solenoid, it sucks in that valve, releasing the seal, allowing a free flow of air from the charcoal canister through the valve into our intake manifold. That's pretty slick. I think this is reusable. Well, that's the purge solenoid, how it operates, how it fails, and how you can test it. If you're like, I don't know anything you just said, click on this video, it'll all make sense.